Okay, let's see the code for the K-means. Well, the first part is I created a dataset with a total of 4 clusters, and just run this line of code and you will get exactly the 4 classes like this. So 4 clusters, and one cluster is pretty much isolated, and then the remaining 3 of them, they are kind of well tightly squeezed tightly together. Okay, and then we import the k-means from the scikit-learn, and then when we create the k-means model, we want to specify the n clusters to be 4. So well, we are cheating in this case because we know there are 4 clusters. And after that, if you want to know the centroids, well, you can do the k-means dot cluster centers, and then you will get this, the xy coordinates of the centroids. Well, if you want to do k-means dot labels, and then you get the cluster labels. Okay, so the next thing we want to do is we want to do a comparison. So, well, remember when we created this set, we know there are 4 clusters. So we have already got the labels of all the original data. And after we have done the k-means, and we also have the k-means dot labels. Okay, so if we want to visualize those two different scatter plots and using the original labels and the cluster labels, and we see those two graphs. Well, and if I ask you well, have we done a good job in clustering those samples? And you may find, okay, like this one, this is the purple class, and then, oh, sorry, this is the purple cluster from the k-means, and if you're using the original label, and then we have a red class. So what does this mean? Well, in this case, remember for the k-means, we well, say the red may mean 1 in the original class label, and when we are doing the k-means, and then we may have this cluster as a cluster number 4, and that causes the difference. But if we ignore the colors and we just see where are the centroids, and then how are those samples clustered, and we can say, well, we got pretty close clustering. So even though those 3 clusters, they are kind of squeezed together, and then our centroids are at the right locations. Okay, and well, another thing I want to try is how about we just cluster all the samples into 2 clusters. So then I specify the n cluster to be 2, and then I do this comparison again. And for the k-means, it's not a big surprise, and one centroid is here and another centroid is here. So for those 3 clusters, they are combined into one big cluster. Okay, so the next I'm going to give you a new data set, and what you need to do is you want to do a exploratory data analysis first, and after you do the exploratory data analysis, you pretty much will know there are 3 clusters, right? And then after you have done the k-means model, and now you will have a new set of samples, and what you need to do is you need to use the trained k means model to do the predictions and cluster those new samples, well, in the additional dataset. Okay, so go ahead and try to write the code for this part. And so what you need to do is, well, you need to create the k-means and then train the model, and then using the new points, the new dataset, and then do the prediction. So, well, and then you should be able to get the cluster labels of the new samples. So go ahead and pause your video here, and well, finish this coding, and then I will see you very soon. Okay.